Hello everyone, and thank you for joining us for today's Skill Good video, Harnessing the Value of Unstructured Data with Computer Vision. My name is Bianca Ribeiro, and I am a Data and AI Consultant at Thoroughgood, and I'm joined today by my colleague and fellow Data and AI Consultant based in our Brazil office, Fernando Takeshi. We'll be spending the next 20 minutes or so sharing more about the difference between structured and unstructured data, introducing computer vision, and how it can be harnessed to generate value for organizations' unstructured data, culminating in a demonstration of solution that we have delivered. But first of all, we start with the basics of what is unstructured data as opposed to structured or even semi-structured data. Structured data is highly organized and easily searchable, often stored in databases like SQL. It includes data in tables with rows and columns such as sales records, customer information, or insurance claims. Each piece of data fits neatly into a predefined model, making it straightforward to query and analyze. Structured data is the backbone of traditional management systems, enabling efficient data retrieval and reporting. There is also a concept of semi-structured data, which has some organizational properties, but not enough to be fully structured. Examples include XML files, JSON documents, and emails with headers. This type of data contains tags or markers to separate elements, providing more structured and unstructured data, but still requiring some specialized tools for analysis. However, on the other end of the spectrum, unstructured data refers to information that doesn't have a predefined format, data model, or general organization, making it challenging to analyze with traditional databases and similar tools. Think of emails, social media posts, images, or multimedia files like videos. These files may contain valuable insights but lack clear structure for quick analysis. Today, we'll be exploring how to unlock value from this type of data. Now that we've defined unstructured data as opposed to structured or semi-structured, we'll now introduce computer vision and how it works as an offering that allows you to derive meaningful insights from your unstructured data at a scale. Computer vision has rapidly grown in prominence and powers many technologies we use daily. Text recognition, or OCR, converts printed text from images into editable text, used in digitizing books and extracting information from receipts. Attitude detection identifies objects' boundaries within images, crucial for medical imaging and autonomous driving. Facial recognition analyzes features to verify identities and enhancing security in smartphones and surveillance systems. Beyond these, computer vision includes image classification to label objects, object detection to locate items and scenes, semantic segmentation to understand image content at the pixel level, and 3D reconstruction to model environments. Each technology unlocks new possibilities, but fundamentally, they are all making sense of unstructured information. So, how does computer vision work? As a quick and high-level explanation, image recognition using deep learning and neural networks works through a process called convolutional neural networks, or CNNs. When an image is input into the system, it's broken down into pixels and processed through multiple layers of neural network. Each layer of the CNN extracts different features from the image, starting with simple edges and textures in the early layers to more complex patterns and shapes in the deeper layer. These features are then combined to recognize specific objects within the image. The neural network is trained on a vast data set of labeled images, learning to associate certain patterns with this specific label through a process called backpropagation. Over time, the network adjusts its parameters to minimize errors and improve accuracy. Once trained, the model can accurately identify and classify objects in new images. This is fundamentally the premise of technology that powers the very similar offerings we'll explore in a couple of minutes, from the likes of Google, Microsoft, and other vendors. Now, I'll hand over to my colleague Fernando to share some use cases of computer vision, followed by our document intelligence demo.
Thank you, Bianca. So quickly, just before we share a demo of computer vision in action, we'll now share a view of general types of applications of computer vision, as well as discussing the different services that are available in the market from leaders in the data and AI workspace. There are a range of potential applications of computer vision for enterprise organizations across industries. We'll be introducing and then demonstrating a document intelligence business case about ingesting insurance information from unstructured data sent by brokers and customers to aid with underwriting and exposure management processes later today. But you can also consider a retail and consumer goods business case where store shelves can be scanned and analyzed for stocking and planogram purposes. Pharmaceutical companies can identify any minute physical defects with the drugs they're producing. And insurers can analyze industrial sites or buildings to understand any damage or erosion to other risks via visual scans of the insured property. Of course, the document intelligence business case we'll be featuring today is highly relevant as it's applicable across industries and organizations. As mentioned previously, there are various computer vision services available from leading data and AI and cloud vendors, empowering businesses with advanced image analysis. Amazon Recognition provides facial analysis and object detection. Cloud Vision AI excels in image labeling and OCR. Microsoft Azure AI Vision offers robust capabilities in object detection and spatial analysis. IBM Watson Visual Recognition specializes in custom model training for specific tasks. And Databricks, in conjunction with Labelbox, offers a compelling computer vision solution that works within Databricks Lakehouse framework. With this context on unstructured data and computer vision shared, we now share computer vision in action as part of a solution that we have developed for a client. We finally got there, and now that we have walked the stepping stones and have laid the foundations, let's see a real-world live application. The use case we have today looks at how one of our insurance customers was able to leverage AI to extract custom fields from unstructured documents. Insurance companies receive a large number of unstructured documents, be it pre-bind contracts, market reform contracts, or called MRCs, schedule of values and submission documents, and it mostly ends up being a manual process to extract relevant information from it. The extracted content is then provided to underwriters for them to carry out risk assessment, underwrite policies, and track and evaluate claims. Improving the efficiency and auditability of these manual processes will provide a significant competitive advantage to businesses. Modern data platforms, such as the ones I just presented, provide AI services that can leverage machine learning to extract information from documents automatically, accurately, and repetitively. In the demo, I'll be utilizing a service from the Azure AI toolbox called the Azure Document Intelligence Service to extract required information automatically. That can save a significant amount of time compared to a manual process while gaining accuracy and fast auditability. So this is a more detailed view of the solution architecture. Starting on the left, Form Recognizer trains on the set of documents, creates a neural model, and then can extract the similar information on the clean set of documents. On top of that, we can build Databricks notebooks to call our model's endpoint and further create the data. For today's scenario, let's imagine the broker sends initial quotes containing information about insuring hotels. These forms can be in different formats, but all of them contain different information that I am interested to extract and further analyze. We will use Form Recognizer to model the patterns which information comes in. So let's now open the Form Recognizer Studio. Right, so this is the Document Intelligence Studio. Here we can see on the left all the tabs that we'll work with today. We'll start on the first tab, the Label Data tab. This is where we can train our model on a few of our documents. As I stated earlier, we'll work today with insurance documents, more specifically in hotel risk assessments. You can start by looking at an unlabeled document. All information is laid here in different fields, which can vary from document to document. This is where our fields come in. I can come over here to the right, click Add Field, and create what our labels are going to be identified in specific documents. Then I can auto-label, tie our analysis to a specific model, and start the auto-labeling process. Once that is finished, the model will then look for all the labels that we instructed it to look at and build a model that will then be able to identify other documents with the same labels. The end result will be a labeled document where all of our little fields here will appear tied to a certain field. Let's wait for it to load. Right, and this is how our document looks after labeling. You can see that the model did a pretty good job at finding the different fields that we were looking for. Nice. Next, our models will sit here within the Models tab. This is our model. Here we can see a few more details about it. We have all the fields we need. Our last tab here is Test tab, where we can properly test our model. First, I've selected my model here on the top. We will now upload a document for it to run on. Right, if I click here on the Run Analysis, the model will take a second to run our model on top of our uploaded document and retrieve what fields could it find, and also retrieve a confidence level on each of these fields. Now you can see how good of a job did our model do. We can see that it labeled correctly all the fields that we wanted it to label, and also returns here a confidence level. For this case, we have 52.2%, this one 92%, and so on. Right, this is not very practical or scalable, right? We cannot use this to analyze a large number of documents, and this will also take a while. That is why we can use something else to query the endpoint of the model and then analyze it on a bunch of documents. This is where Databricks comes in. We use Databricks in this case to connect to the endpoint of the model and run a loop on top of it, querying our model and running it over our own documents to then start this analysis data on something like ADLS. The documents can also be stored in ADLS or in AWS if you use that as well. Once the documents are analyzed and that data, that aggregated data is available in ADLS, you can also further curate it, aggregate it, and analyze it in any tool you like. But we did it here with Power BI. Here you can see the aggregated results of our analysis running on top of the documents that we analyzed. It is an interactable report where you can see the results and accuracy for any of the documents you might have analyzed. You can also see an average of field confidence and a breakdown of all of the fields. What I have just shown you is not at all limited to a single kind of document or to a single industry, such as the insurance example we just showcased. Every industry works with a large number of documents which can take advantage of these techniques. And as I alluded to earlier, switching from manual to an automated AI-driven process not only contributes to efficiency and accuracy, but to auditability. The key message here is that AI models are not necessarily black boxes and lone tools. They can be used to augment parts of the processes and improve their effectiveness. We lay down here a long-term vision with increasing levels of complexity in your AI journey, illustrating how can the automated extraction of text information be just the first step in a path to advanced use of AI tools. The application possibilities stack upon each other, including extraction of key phrases and entities to make search more targeted, leverage pre-trained models of Azure Cognitive Search to refine capabilities, use GPT models to build Q&A functionality, relying on golden record, fine-tune existing assets, and explore the potential use of LLMs. And we can help you to walk those steps. For those of you who don't know Thorogood that well, we are a specialist independent consultancy which operates globally within the data and AI space. Our products fall into the general categories of data engineering, data visualization, and data science, as you saw today. But essentially, our business is helping our customers to make sense of their data using analytic solutions. That can include data and AI technology strategies, end-to-end implementation of cloud solutions, user empowerment, and AI workflows. Our niche and approach is rooted in understanding the business of goals and customers and using the capabilities of technology to meet these goals. Because of that, customers and their businesses' objectives are at the forefront of our approach. And these are some of the clients that we have worked with. We proudly delivered a number of solutions which keep helping customers on a daily basis across the globe. I have mentioned earlier, but we are an independent consultancy, and that means that we are not tied to one specific technology, and we'll be able to help you with the best offer on the market that fits our needs and goals. If your organization is already familiar with Azure, for example, we will be able to leverage that and implement solutions as the one you have seen today. If on the other hand, your organization prefers AWS, count on us as well. With that, we wrap up today's video. Thank you so much for your time and see you on our next event.